I am Sukit Sirivadana, the president of the society, and it is my pleasure to start off this event where we hope to provide valuable insights into the little known middle ground between the digital realm and the physical world of civil engineering. Without any further ado, let me introduce today's esteemed guest speaker, Engineer Sunet Salavuvidana. Engineer Suret Salavavidana holds key positions as the Additional Director, Highway Design, and Additional Director, Information Systems and Network Management at the Road Development Authority. With over 15 years of experience in highway design, Engineer Salavavidana has contributed to several mega-scale infrastructure projects, notably the Central Expressway and the Ruwanpura Expressway. He holds a Bachelor of Science in Civil Engineering from the University of Peradeniya, as well as a Master of Engineering in Highway and Traffic Engineering from the University of Moratuwa. In addition to his professional roles, Engineer Salva Vidana is a highly regarded professional review trainer for the Chartered Engineer qualification at the Institution of Engineers Sri Lanka. He also serves as a visiting lecturer and Viva panelist at the University of Moratuwa, as well as an external supervisor at the University of Sri Jayawardhanapura. His expertise is further shared through his role as a resource person at the IESL. Engineer Salavavidana is also a professional member of the Computer Society of Sri Lanka, reflecting his contributions to both engineering and information systems. Sir, I would now like to cordially invite you to deliver your valuable words.
Okay, thank you. Can you see me? No, right. So I believe now you can see me, right?
Yes,
Okay. So how is life going on? Studying, I think most of you are final years. So I'm really happy to give you an address on the current trends in civil engineering as well as IT and how we are going to combine these things. So I think this is my first time in KDU, and very glad to all the fresh blood that are entering civil engineering field in the future, in the very near future, I think. So so we shall start our lecture. Mm, yeah. Right, guys. Now today, what I am going to tell you is, so I just want to make this an interactive session, right? So what I am going to tell you is that is nothing about civil engineering or it is nothing about IT, right? So I think as civil engineering final students, you have a very good understanding what is civil engineering, and not like our days in this modern era. I'm pretty sure that you know lot of IT and elite sciences. Okay, so what I am going to tell you today, or what I am going to describe you today, is how we are going to bridge the gap between these two fields. Okay, so what is this bridging and why is it necessary? So these are the things that we are going to discuss today, right? So first of all, we shall just have a look. What is civil engineering? Okay, so everybody knows what is civil engineering. So it is a profession of planning, designing, and executing structural works. Okay, so few examples are dams, bridges, highways, aqueducts, canals, sewerage systems, high-rise buildings, and anything you name, you can construct using civil engineering. Okay, that is using the structural methods and structural calculations, and that is not only structural. So as an example, civil engineering is having three major fields. You know, there one thing is structural engineering, then highway engineering, then hydraulic engineering. And very recently, there are many other engineering fields that are coming as subcategories of civil engineering. So, do you know why it is called civil engineering? Right? Why it is called civil engineering? You know, in the 19th century, 18th century, and the 19th century, most of these structural works were carried out by the military, especially under the colonial administrations. The colonial administration is not only the British, there were various colonial administrations like, you know, British, French, the Portuguese, and up to the First World War, there was German administration also in Namibia and things. So most of these structural works. So what is this structural works? You know, when it comes to when they go and conquer one country, they want to have some say you know, when the British conquered Sri Lanka in 1950, there were no passable roads at all. Okay, these Portuguese and Dutch, they were not very keen on building roads, so the British had to start everything from the beginning. So that was in you know, in 1820s that they started the first road from Colombo to Kandy, right? Now when you go and start constructing these roads and things, you want to have, you know, the bridges, culverts, and then, you know, drainage structures and all these things. So these things were usually carried out by the military engineers. Okay, so because you know, when these imperialists went to many countries, they didn't have lot of other people at that time to engage in these activities, so they engaged the military. And you know, these countries were not very safe for Europeans to come and work. That is why earlier every engineering work was carried out by the military. And then later, when the empire expanded, okay, when the empire expanded and the military was not adequate to do all these structural works, then there came to the arena the engineers from the civil society. They were not military people. Okay, then therefore, most of these engineering works, you know, earlier it was carried out by the military, then civil people were going to do these things, but they are engineers, graduates, right? Now, the people started telling, say, this bridge was carried out by the military department and the other bridge was carried out by the civil department. Okay, so like that, the term civil came into being. Okay, there is nothing other than this, there is nothing why it is called civil engineering, because you can't call it just civil, because you know, now if you are going to build I mean, if you are going to build an engine or something, that is also civil work if it is being carried out by engineer from the civil society. But that is not that. At that time, most of the engineering works were the works now what we are called civil engineering. Okay, so this is just a little bit of history. The first man to call himself he says himself a civil engineer was Mr. John Smeaton. Okay, right. Then when it comes to information technology, so what do you mean by information technology? IT. It is usually abbreviated as IT. It is the use of computer systems or devices to access information. Okay, you know, there are two terms. One is information, the other one is a technology. So, technology to transfer information. Okay, so that is what you call the information technology. IT is a broad term that involves the use of technology to communicate, transfer data, and process information. And these are the subcategories that IT has evolved into. What are these? Analytics, automation, artificial intelligence or AI, cloud computing, software development, communication, cybersecurity, DBMS. What do you mean by DBMS? Database management systems. Okay. IT infrastructure, maintenance, and IoT. What is IoT? Internet of Things. So we are going to discuss them in detail, right? And machine learning, networks, robotics, and AI. It's the same thing as a artificial intelligence, right? So this is information technology. Then our problem is why IT is necessary for civil engineers. You know, I'll tell you one thing. I entered the university in year 2000. Okay, were you born? Maybe not, right? So that was in year 2000. You know, things were so much different from today. Okay, most of the things, because at our time, so I entered University of Peradeniya for my bachelor's degree. At that time, you know, uh, computers were very rare. It was not the kind of a home gadget. Okay, now everybody is having a computer or laptop. Okay, but that was not the case at that time. Do you believe when our batchmates came to the university for the first time, some haven't, some hadn't even touched a computer at that time. Okay, some hadn't even touched a computer. So very few know how to do, at least how to type. Even typing was not possible. Okay, and maybe you don't know. It was somewhere in Sri Lanka. It was somewhere after say 1998 or 1999. We had these Windows things, right? Before that, we had DOS. Okay, so DOS is, that's kind of a very troublesome thing. So we have to. It is only the black screen, and the the texture in green color. Okay, so that is in LRT monitors. So the monitor was black, and there came shining little green letters. Okay, so you had to type all the command to get something done. And then there were the DOS was there, and there was some language called Pascal. Okay, that is to do the calculation and things. And these were the norm of the day. And when it comes to calculation, either we had to use the calculator or we had to do it manually. Okay, report writing, that was all manual. Okay, so you had to get some A4 papers and get your pen and ruler, and then you had to do all these the report writing and everything. So the things were very much different. At that time, there was no clue how civil engineering and IT would be connected in the future, because you didn't want IT at that time. When it comes to surveying, it was the theodolite. Okay, so all are kind of some mechanical instruments. Okay, you didn't want to insert a battery to work there. Okay, and when it comes to engineering drawing, that was manual, right? That was manual. So you had to have the your ruler, and then your very big sheet, A1 sheet or something like that, and then your sharp pencil, and then you have to draw. All these things have now changed in the course of 25 years. Okay, all these things have changed. Now nobody is using, even the civil engineers, they are not using pen, pencil or piece of paper. Okay, so we have taken ourselves into this revolution of information technology. So everybody is using the computer. Everybody is using software. Okay, but this is not what I am going to talk today. Okay, please understand, information technology is having some broader context. Okay, so information technology can be using MS Word, that can be using MS Excel, that can be using MS PowerPoint, like now I do. That is also information technology. So that information technology in a clerical way has come into each and every field. That can be civil engineering, that can be education, and that can be psychology, that can be medicine or whatever. So information technology has crept into these fields. But that is not what I am going to talk today. What I am going to talk today is the specific use of IT in civil engineering. So that means they are tailor made for civil engineering tasks. Okay, so these software and these technologies and all these, there are IT things that are tailor made for civil engineering works. That is what I am going to introduce today. So I think most of you know these things. Okay, because as you are you are learning in the third decade of the 21st century, you should be aware, and you have the internet, so you can search anything and study, right? But what I am going to do today is, then what is my role if you know all these things? Huh? So my role is, now today what I'm going to tell you is, I'm going to tell you the significance of these technologies. That's all. Okay, why they are significant and why you have to learn them, right? So we'll go into lecture. This is one of such technology that we have some enormous use in the civil engineering, that is GPS, or global positioning system, right? So what do you mean by the global positioning system, or GPS? The GPS is a US owned utility that provides users with positioning, navigation, and timing services. So, can you see that here there's a control segment in America that is called the ground station, and then there's the space segment, that is satellite, and then the user segment. So, what it does is, now using these satellites, this control segment can give data, give and receive data, and they are giving information to these people, registered users. Okay, this system consists of three segments: the space segment, the control segment, and the user segment. The US Space Force develops, maintains, and operates the space and control segment. So these things we cannot touch. Okay, they are owned by the US Space Force. What we can do is use in the user perspective. So you have to have a GPS receiver, right? So how do you use GPS in civil engineering? In civil engineering, GPS surveying plays a vital role in tasks like land surveying, construction layout, and infrastructure planning. So here, this is a GPS receiver. Okay. By using GPS technology, engineers can quickly and precisely determine property boundaries, locate structures, and establish reference point for construction. Now before the GPS came into being, how do you know the coordinates of one point? Maybe just think that you are given some task. Say you are given a task to survey some trace for, say, Ruanpura Expressway. Okay, just think, now you are living in 2000. Okay, so you don't have GPS with you. So how do you find the coordinates of the points? Now at that time, the service department of Sri Lanka, they had some designated points spread or scattered throughout the country where the coordinates are known. Okay, so now what you have to do is, you have to pay some money to the service department, and you have to get one of that points open, and then you have to do a flyback from that point to your area of interest. And now then you have some control point there. So you have to do the flyback, and then you have to get the error, then you have to distribute, and then you have to mark one control point in your area of interest. One may be not enough, maybe will have to have three. Okay, and then again you have to do flyback. So you can understand what the troublesome work was that. But now, if you have this GPS thing, what you can do is, you can just go and check what is the coordinates there. Look how this information technology has made a civil engineer's life easy. Okay, so this method eliminates the need for traditional surveying equipment such as total stations and theodolites, streamlining the surveying process and saving both time and resources. Okay, now but I have to tell you one thing. We have these new technologies in our hand. Now I'm talking like a civil engineer, right? But you know, when did they mark, right? When did they mark the boundary between, okay, when did they mark the boundary between USA and Canada? You have an idea? That was somewhere in 18th or mostly, as I remember, it is 19th century. You see the theodolite. Okay, more than 4,000 kilometers. Just seeing the accuracy. Okay. Otherwise, if you start from somewhere in New York, when you go to Los Angeles or there, the California, at the edge of California, maybe we'll go from New York to Alaska or to the North Pole if you didn't have the proper mechanism for error distribution. But they had done it without IT. And today, even with all these new technologies, most of the time people are going to make mistakes. So that is the problem with the technology. Even if you're having the technology, the errors cannot be omitted. But only thing is time and resources. Okay. So GPS surveying allows for real-time data collection and integration with geographic information system, that is GIS, and we are going to discuss it next, enabling engineers to make informed decision based on up-to-date information. So wherever you go, you can know what is the coordinate. Overall, GPS surveying is a game changer in civil engineering. Okay, remember the word game changer. Why? Offering unparalleled accuracy, efficiency, and versatility in data collection and analysis. That is not only for surveying, right? Say, just think that you want to go and check where your bridge is, where your say some archaeological monument is. Just think when you are going to plan a new road or something, so you go and mark the archaeological monuments. Now then, what you do? You plan the road so that everything is gone. Okay, not here in Sri Lanka, right? If it is in America, of course you can, right? But in not Sri Lanka, Sri Lanka, you have to save the archaeological monuments. You can't go and touch them, right? So now, when it comes to GIS, what is this GIS? Here, these are the parts consisting of GIS. There's software called SCADA, automatic vehicle location, outage management, service order, customer information, substation, regulator and other records, work order history, mobile maps, line patrol and pole testing records, advanced meeting infrastructure. So the GIS can be used for planning, data collection, analysis and construction. So let us discuss what is GIS or Geographical Information System. Geographic Information System is a system designed for capturing, storing, manipulating, analyzing, management and presentation of all types of geographical data. Okay, so you can capture, store, manipulate, analyze and manage any kind of geographic data. Geographic Information System has found applications in almost all fields of study, and it is an important tool that is enhancing these fields. Okay, so what is the use of GIS? So GIS links different aspects of engineering projects such as emergency planning, history and even geology specific point on a map. So just think that you want to have you know that there are some different type of soil or different type of geological features in some area. So if you want to mark them on a map, in 3D map, you can use GIS. Okay, so it is not very simple like GPS, right? GPS is just like taking coordinates. Here, this is kind of a map. Okay, map, and you are going to using some reference system, you are going to mark them. GIS is beneficial in almost every organization or industry, and of recent reason there has been greater awareness of the economic importance of GIS. GIS is a precise analysis tool, and its output is only as accurate as what you input into it, right? So that is the problem with the computing, right? Garbage in, garbage out. If you give bad data, you are getting bad results, right? Uh, then, remote sensing is another such technology that you are having lot of benefits in information technology. Okay, what is this remote sensing? Remote sensing is one advance that allows for remote monitoring on site with minimal interference from physical presence. Now, do you know, have you heard now very recently, China did a road something like I think 1 kilometer something using fully manless equipment. Okay, so their rollers didn't have men, and their the machineries didn't have men. Nothing. Just like it is just like a ghost film or a horror film where the instruments and the vehicles were working without people in it. Okay, so how did they do that? That is using this remote sensing technology. Okay. Civil engineers can now monitor construction progress from the comfort of their homes thanks to remote sensing technology. Okay, so now you know, now those days, of course, construction progress, you had to go to the site. Now just think that you are living in Colombo and your construction site is in Jaffna. Okay, so how do you go and the monitor the progress? Actually, you had to fly to Jaffna or you had to travel to Jaffna and then do it using your physical eye. But it is not the situation now. Using this remote sensing technology, you can do it at the comfort of your own home. Civil engineers can use remote sensing to monitor the progress of a construction project without being physically present for any part of it. Okay, so that means now you can stay yourself maybe in Colombo or Delhi or London, and you can still monitor the project that is happening in Simalandu. Okay, they'll be able to see what is happening in real time through live video feeds or take pictures and videos with drones that fly around taking photos from all angles. Okay, now do you remember these spellbinders? That was a kind of some Australian TV show somewhere in I think 19 at the end of 1990s or at the beginning of 2000s. Okay, there when the tribesmen were working, these helicopter like things are coming to check how they are working, right? So it's the same thing. Well, it was a magic at that time, but it is no more magic. It's a reality. Okay, now people are working in the construction field, then a drones are coming to check whether they are working properly. Remote sensing would not be possible if it wasn't for today's mobile and cloud technology. So right, right. Now time, right? So anyway, so we'll go back to our lecture. So remote sensing would not be possible if it wasn't for today's mobile and cloud technology. So we were talking about the cloud, right? And then the cloud technology enables the possibility to access, modify, and manage data stored in remote servers, right? So this remote sensing, so it can be used for urban planning and development, environmental monitoring, structural health monitoring, geotechnical engineering, water resource management, transport infrastructure planning, coastal and ocean engineering, mining and mineral exploration, agriculture and crop monitoring, disaster management, and energy infrastructure planning. Right? So this is how we can use IT for civil engineering. Right. Then we are going to talk about Internet of Things or IoT. Right? Have you heard about this IoT? So that is very common these days. It has become a jargon, IoT. IoT is, that things are being interconnected using information technology. Okay, so that means IoT can be used, that is not in civil engineering. So you can use IoT to control your refrigerator from your office or your air condition from your office. Just think that now of course in Sri Lanka this is not the problem. We don't have very cold climates or very cold seasons, but just think in some European country or some North American country that you are coming from the office and you want your house to be warm when you reach there. So what you can do is using IoT, using your smartphone, you can set that. So you are reaching, say you are reaching your home by 7:30 p.m. and from 7 p.m. The house starts warming itself. Okay, so this is one kind of a very small use of the IoT technology. In today's industries, oil and gas, manufacturing, food, dairy, civil engineers are not only responsible for designing and building infrastructure that sustains us, but also creating automated systems to help make our lives easier. So this is why Industry 4. What do you mean by Industry 4? This is called the fourth industrial revolution. Okay, now you know fourth industrial revolution is there. Now with that only we have come up with lot of information technology things into our industries. Okay, so it is coined as Industry 4. So it focuses on improving production efficiency by allowing automated machines to communicate with each other without human intervention. So that means machines are communicating with each other using sensor networks connected via Internet of Things. The Internet of Things is one step closer to reality. As more smart devices become interconnected, this opens up a whole new level of innovation that will change everything about how we live and work in our city. Okay, so that is a brief introduction about IoT. So how you can use IoT for civil engineering, right? So one thing is wearables. Devices like smart helmets and connected work boots are starting to populate construction sites, in turn boosting safety and efficiency. Okay, so they can communicate among each other. No, it is something like this. See, now everything is connected like this. This is the Wi-Fi sign. That means they are being connected, right? Safety sensors. Maintenance sensors can notify teams when equipment needs repair, or maybe there's fire or something, helping prevent breakdowns or malfunctions that could endanger nearby employees. On-site IoT sensors can monitor for hazards like toxic fumes or high temperatures. So you can give early warnings with the IoT. Just think that now there is some fire is going on. So your helmet tells you, sir, there's fire going on in this side. Okay, so something like that. Okay. The material monitoring. Construction sites can also use IoT devices to monitor their materials. Concrete sensors are one of the most prominent examples. By placing concrete sensors in concrete, construction teams can remotely check in on the curing process or see if it needs repair. Just think that you can check the temperature there. Okay, whether it is coming with the whether the curing process is going on with the relevant temperature, right? Theft prevention. Connected drones can patrol work sites without needing a human security team. These machines can discourage would-be thieves as they fly around the site, and if someone does steal something, their video footage can help track them down. Okay, so that is how the IoTs are helping the civil engineers. Then this one I think all of you know, use of CAD software. CAD enables civil design engineers to create design concepts for civil engineering projects using highly accurate and detailed digitally produced 2D drawings and 3D models. Okay, now of course the digitization of highway design we started somewhere near 2007 using civil 3D software. Okay, now it is still ongoing, right? So the scope of civil engineering industry is one of the broadest out there, but CAD is used in virtually every facet of the design process, no matter the project and the project at hand. So that can be roads and motorways, bridges, pipelines, airports, docks, dams, and things like that. And the final candidate is the building information modeling, BIM. I think most of you know BIM. So that is the newest technology. Building information modeling or BIM is a building design technology that starts with creating an intelligent 3D model. The most advanced BIM software systems include a database of all related building information and intelligent data, including construction sequencing, cost, and lifecycle management information that allows for document management, collaboration, and simulation throughout the lifecycle of a project. Now, just think that you are going to build a road, right? Now, usually the roads are built in this country by Road Development Authority. And what about water? That is by National Water Supply and Drainage Board. And the electricity, that is Electricity Board. And telecom, this may be using Sri Lanka Telecom. Now, if we can build a 3D model of a road, now we can give that to the water board and say, okay, insert your pipes here in the model first. Okay, and once they have inserted the model, the pipe models, we are asking electricity board, okay, now you insert your the electric poles or something, and we ask telecom, okay, you insert your telecom poles or something, right? Now finally what happens is, once this 3D model is being built up, we know where the pipeline is. So that means after some 25 years, the water board does not want to go there and dig blindly to find their pipes, because the model is there. Just think that you have had some fiber cable or something there. Now the Sri Lanka Telecom does not need to come and dig blindly the road to find their fiber optic line. They know where it is accurately. So that is what you mean by beam. That is only one part, right? And other thing is, you can just check their progress, the construction progress, right? It is like you can use it for design, build, and operate. So the beam technology is used in planning, design, construction, and operation. And these days, of course, we are trying to bring that technology to Sri Lanka. Okay, so that would be the next revolution of highway engineering, because usually when it comes to the utility services, all utility services in Sri Lanka are running on our roads. Okay, so road development authority is the best place to start this revolution, and that is exactly what we are trying to do these days. Okay, and big data. So what do you mean by big data? Big data is unclassified data. Just think that when it comes to some traffic data or something, so there can be traffic speeds, the types of vehicles, the vehicle classification, and then the green times, and then the vehicle, I mean the road blockages, all these things, this big data unclassified. So you are getting all these things. Okay, big data is basically a large quantity of data stored in a single source, using which the professionals could carry out further processes as and when required. So all data are stored in one location. You go and pick them, what is necessary. Just think, as a traffic practitioner, I want some traffic data, the turning movements. So I go and pick that. So another person, just think that he is a highway designer, he want to find the AADT. Okay, so he goes and pick that data out of the box. Okay, big data collects the data and is analyzed in order to use it as information. So what is the difference between data and information? Data can be anything, unclassified. Information is that you have modeled it, so that can be readily used. Okay, big data engineering enables systematic and precise analysis of the acquired data from unstructured sources such as cell phones, cameras, sensor equipment, and log files. Incorporating digital technologies and tools such as big data, data intensive industries can benefit a lot from it. Okay, so how you are going to use big data in civil engineering? So that they can be used for enhanced design and analysis. These all are thanks to information technology, right? Otherwise you can't extract data and store them. Predictive maintenance and asset management. What is this predictive maintenance? Just think that there is a bridge and bridge is being decayed, so you are getting some data. So what is the strength of one component? Okay, what is the load bearing capacity of that component? So you are monitoring it, and then you are storing it somewhere there as big data. Later, when you want to get information, you can go pick them. Then construction project optimization, sustainable infrastructure development, urban planning and traffic management, the risk assessment and disaster management, right? So then 3D printing solutions, I think you know these things, right? 3D printing, of course, that is being used especially in Far East countries to quickly build houses and things. Okay, 3D printing also known as additive manufacturing, is an innovative process of creating three-dimensional objects from computer design CAD models. And then what do? They go and construct it. It operates on simple concept called layer by layer construction. 3D printing adds material in successive layers to build an object. So like this. Okay. This process begins with a digital 3D model designed using specialized CAD software obtained through 3D scanning technologies. The model is then sliced into numerous thin horizontal layers to create a digital blueprint. These layers guide the 3D printer as it deposits material, typically plastic, concrete, metal, or other composite materials, by following the precise instruction from the digital design. Okay, so this is something of a very sophisticated technology. So that is how information technology is going to help the civil engineers to do their tasks efficiently and effectively. So our next question is how we are going to bridge the gap between civil engineering and information technology. So civil engineers, in order to bridge the gap, they have to study these essential software like AutoCAD, Start Pro and SAP 2000, Civil 3D, ETABS, Revit, Tekla Structures, Bentley Inroads, Rhino 3D, Primavera. So these are some of the advanced software that civil engineers need to learn in their life. So I think it is high time in the final year you start learning these things because this is the future of the industry. It is not that now just think that that time uh, when you went to an interview they would ask you, do you know how to calculate, so can you draw something like the loading diagram of an arch or something. Okay, but today we will not ask you that question. We will ask you, do you know Revit, do you know Civil 3D, do you know Primavera, have you worked there? So this is how the things have been changed. Okay, this is how the things have been changed. Now you know it is no point just learning how you are going to have the load distribution of an arch structure, because you can just go into the internet and find it. Those days when there was no internet, of course, the people had to memorize them. Today, no. Okay, so whatever that can be stored somewhere, you need not to remember. But only thing is, you should know how to use them. That is why people are worried that AI will replace them in the future. Yes, they would. But only thing is, then who is having the jobs? Those who will have the jobs are the people who can effectively use AI technology for their day-to-day work or for their engineering designs or their industrial maneuvers. Okay, so this is how the information technology is shaping the world in the future, and how you as civil engineers have to get into the ship. Otherwise, you will be ignored and you will be buried in the sand of time. So what I suggest as a senior engineer is, guys, start learning these things from the beginning. Okay, when you are in the final years, start learning some software. It is not a big thing. Okay, so you can use your free time to learn some software. When it comes to the traffic modeling, there is a very famous software called Visim. Okay, so very few people are here in Sri Lanka who can conveniently handle Visim. But when it comes to planning, Visim is very much important. Okay, so why our infrastructure projects tend to fail is we don't have a very thorough planning phase. Okay, so for these kind of things in the future we want planning engineers. So we want to have engineers who know how to handle Vism comfortably. Okay, and there is another software called Visum. Visum and Visum. So Visum, I think Visum is micro, Visum is macro, something like that, right? And so when you are going to do the BIM, so you want to know Revit. So how to study these things, and And I think the civil 3D guys are also having some software like Inroad or something. Okay, so these things that you have to learn from the beginning. And civil engineers learning essential IT skills: computer design, BIM, cloud computing, project management techniques, IoT. So you have to learn these things, right? So this is how you are going to bridge the gap between civil engineering and IT. Don't think an IT personnel can come and do your job. That is not possible at all. So the requirement of tomorrow is a civil engineer with some IT knowledge, okay, who can handle civil engineering projects using the modern technology. But how? How you are going to learn these things? Okay, so that is our next question. So it is easier said than done. Okay, so anybody can say, okay, so you have to learn some IT or something like that. Okay, come with some IT knowledge. But how you are going to do that? So that you can do using part-time IT courses. Now so many courses are there. Some are in Sri Lanka. Some you can pay and learn through internet. Okay, and joining professional IT societies like BCS and CSSL. CSSL is Computer Society of Sri Lanka, right? BCS, I think you know, British Computer Society. And attending webinars and seminars, CPD activities. When it comes to CPD activities, find some IT based courses. Okay, so these are very important, right? So if there is a new software coming, you have to learn it, right? Now you know software or the IT is continuously changing. Okay, now I'll tell you one thing. Now, as the additional director of information systems and network management, now when I first visited that department of RDA, so I asked my subordinate, so what is the software that you are using? So something was some there. So they said, okay, sir, we are using Python. Then I asked them, but you know that Python is a kind of uh, database management system. Okay, I mean that can be used for database management. So how you can create UI means user interface using that. But then they told me, no, you can use that for the UI creation also. Now you see, within a course of 15 years the software has changed. Those days when I was learning IT, it was just like for data management, database management. Okay, but now it's a complete software that you can use for UI creation as well. So these things are changing. That is why you want to engage in CPD activities. Okay, so those days we used Visual Basic (VB), but now some new software have uh, come into the play. Now you know this is nothing about IT or civil engineering. When it comes to the modern day education, you want to know there is something called learn, relearn, and unlearn, right? Learn, you know. Okay, you learn something. Relearn also, you know. When there comes another technology, you have to relearn it. But what do you mean by unlearn? Unlearn is you have to forget the age old technology. You can't say this is how we were doing this for 25 years. Okay, sir, this can be 25 years, but now the things have changed. So you have to learn the new thing, new technology. And you have to unlearn that what you have been doing for 25 years. So that is the norm of the modern era. Okay, that is why you have to learn, relearn, and unlearn. Right? So that's the end of my lecture. Right, sharp at 8, right? So any questions that you guys are having?
Yeah, excuse me, sir.
Yes.
So before we go into the question and answer session, sir, I
Yeah.
would first like to apologize on behalf of our society for the technical issue that occurred earlier.
Yeah.
We had not foreseen it beforehand, and I think it was our fault, sir. So first of all, I would just like to apologize for the technical issue, and thank you for continuing your lecture and enlightening us with your information. Uh, so yeah, once again, we are extremely sorry, sir, for the technical issue.
Right.
I would. Yeah. So if there are any questions, please feel free to ask esteemed guest speaker. Uh, on
Sir,
Yeah.
yes.
hello.
Yes, I can hear. Yes, I can hear you. Yeah.
Sir, I'm from University of Moldova.
Yeah.
Recently, in our highway engineering society, I have to wrote an article about new technologies.
Yeah.
So I searching the new technologies. I found that the South Korea is tends to use IoT as actually their roads are very dusty and filthy. So and in there are some hotter seasons in their country, and what they do is they are creating IoT systems to uh, wash out the roads in hotter hot
Some.
hot time periods. Uh, so. Sir, and also, yeah, that's the kind of advantage of IT utilization. So, and also the AI, when the AI comes into the play, I saw another technology, the brickworks. It is doing by a machine. That machine is program using some kind of algorithm, and that machine can complete a brickwork, let's say a wall. In a half an hour, the machine can completely finish that wall without any manpower. So that kind of risky to the civil engineering discipline in near future. So what is the idea about this?
Yeah. Now, of course, that is what I'm always telling. Now, you know, now just think about the donor technology, right? So, before 10-15 years, just to get some donor type image or a video, you wanted to have a helicopter and then the pilot, right, and then the cameraman. Now all these three things, or the helicopter, cameraman, the pilot, and everything is being replaced by the drone. So that's a new technology, and it is very much cheaper compared with the helicopter. So that is why, you know, now the technology is improving in leaps and bounds, right? So if you are not going to learn these new things, that you cannot retain yourself in the field. So when it comes to your this Korea thing, of course, what you are telling me, I have been to Korea, so I don't know whether the roads are filthy and dusty. Of course, their roads are very clean, but maybe what you are telling is, sometimes in the summer times, the dust is coming, I think. So that is happening in Sri Lanka as well. So IoT in the sense, so they are having kind of some automatic water showers where when the summer is there, and so they identify that there is dust. So maybe there is some measurement. So this much of dust only they are going to allow. If there is a, I mean, higher than that dust level, they are going to automatically start that water shower or something to clean the roads. I think in Japan also they are having that kind of technology. So that is using the Internet of Things. That, but remember, when it comes to Internet of Things, it is not only Internet of Things. So there are other technologies involved, like cloud technology, right? And then data transfer technologies like this. So what your next one, that is bricklaying something, so that is automation, right? So automation, of course, you can do using IoT, as well as central based system also you can do. Now just think about some in Korea. So I'm not sure whether I am having these photos with me. Now in Korea, they are having for their capital is Seoul. For the Seoul, they are having some kind of traffic control system. Okay, so there are people who are watching every junction, what is happening in that junction. Okay, so they can control the traffic lights and things. So this kind of technology you can use for bricklaying, and in the same time, yeah, it is just like say 3D printing. You can automate the bricklaying as well. So my suggestion is, yes, these things can come, and they are late to come into Sri Lanka. Okay, but Now the things are different. You can learn these things, the technologies, and at least you can have some exposure to these technologies using internet. There are hundreds of free webinars, okay, and some you have to pay, some are free, but you have to learn these things. So when it comes to the field or when it comes to the industry, learn these things and come, right? Otherwise what happens is just like traditional civil engineers who doesn't know even how to type a letter in a word document. So that is a kind of a thing in the past, so we don't have any future with that. Okay, so you are from University of Moratuwa, so did you attend my lecture? You are from final year?
No, sir. I'm third year. Actually,
Third year.
I'm personally messaged it to LinkedIn access, sir.
Building.
LinkedIn, sir.
LinkedIn.
Uh,
What's your name?
and Ashen, sir.
Ashen. Yeah, I remember. Yeah, so very nice to meet you, right?
Yes, sir. Nice coincidence.
Yeah. And guys, another thing what I want you to suggest is, now if you want to learn these new things, of course you have to get I mean you have to register yourself in these international organizations, okay, like ICE, International Institution of Civil Engineers. And there is, if you are interested in structural engineering, there is something called I Structure Engineering. I mean, Institution of Structural Engineers. And then there is this British Computer Society, Australian Computer Society. And have you heard about IET, Institution of Engineering and Technology? So once you register in these things, you get the free webinars and things, so you can listen to them in your free time. And being an old man, I'm still listening, so you young guys, you can learn that, right? So you have to uh, you have to attend these free webinars and get into touch with these new technologies. Okay, just in that, after, I think now most of you may be planning to migrate. So when you migrate there, so what they are expecting is something that is not in Sri Lanka. I'll tell you an example. So I sat for this IC chartered professional review. So what they are expecting is not that you can find in Sri Lanka. Okay. So what they are concerned is mostly about health and safety. Okay, sustainability and resilience. Okay, so these things, they pay a very big focus. Okay, it is not like the construction technology, or the construction technology or construction method or theory. They are not important. You Once you pass out as a civil engineer, your theory is covered. It is just like refreshing what you have learned. Okay, but what you are supposed to do as a civil engineer or a professionally qualified civil engineer is to come up with sustainable solutions. Okay, and make society a better place with your health and safety techniques. Okay, so the things are different outside this island. That is why I'm telling. So always try to get the membership of these international organizations. I think this ICE one is for students, it is free, right? So you can get that. And yeah, that's the way to go. Yes, guys, any other questions? Right, it is 8:10. If you don't have any questions, we shall wind up the session, right? Okay.
Yeah. Hold on, sir. So I believe there are no more questions from the participants to ask our guest speaker. All right. Then I will wrap up today's proceedings. First of all, I would like to thank our esteemed guest speaker, Engineer Sunit Salavidana, for his wonderful guest lecture here today. I think we have all gained some valuable insight from into the world of IT and engineering as well. And we have gained a significant idea of the future trends of civil engineering. And that is very important to us, especially most of us here as final years. So thank you, sir, for your wonderful speech. Next, I would like to thank our society advisor, Dr. Ishani, for her advice and support given to this event. And I would also like to thank our acting advisor, Mr. Damsara Anthony, for his support and advice as well. I would finally like to thank uh, organizing committee here in the Highway Engineering Society of KDU, as well as the participants here today for their interactive participation uh, and questions. So, once again, we, the Highway Engineering Society of KDU, would like to thank you, sir. And we bring this proceedings to an end, and we hope to see you again sometime. Good night.
Okay.